So we have a triangle with corners A, B, and C. We don't know what B is, but we know what A and C is. We're also told that this is the centroid of the triangle. Now, the centroid is like the center of balance. If I was to put my finger there, it would balance on my hand. Now, the next says that AG intercepts BC. So you're talking about the line AG, which actually continues on, and then it hits it at a certain point, P. And it wants the coordinates of P. Now, P might not necessarily be the center of the circle, if you get what I'm saying. Okay, so we don't necessarily know that. As it turns out, the centroid is actually linking any corner to the middle of the line that it's facing. So we actually do know that P is actually the midpoint of BP and PC. So that's what a centroid is. You grab any line and you link any corner to the middle of the next corner, and you can see where the two lines intercept is the centroid. So you would have needed that definition to do this question, and the definition is on the course. Okay, we St. Aidan's lads won't have covered that just yet, but you will do in due time. Now 4-2, okay, is C. So, and then we have to find out what P is. We have to find the coordinates of P. All right, let's continue this. Now, the next thing it tells you is there's a ratio 2:1. So G is 2:1. It's twice as far away from A as it is to G. So G is 2/3 the distance of A to P because it gives you the ratio of 2:1. So that can work out quite easy. So 0 to 6 going all the way to 2/3 and 4/3 is the equivalent of 2 parts out of 3, because going the full distance will be 3 parts. So this is 2 parts is add 2/3 to x, and what's 6 take away 4/3? 6 take away 4/3, and 14/3 to y. So minus 14/3 to y. Okay, this would mean that we're 1 part away. So 1 part would be half of that. 2 parts is 2/3. 1 part would be 2, 1/3 to x, and minus 7/3 to y. So what we can do is we can get this value of g and add on 1 part, and it will tell us the number we're looking for. Okay, it will tell us what we're looking for. We're to the right of 2/3, which means we're expecting a number bigger than 2/3, and we're below 4/3, which means we're expecting a number smaller than 4/3. So we're going to get 2/3, and we're going to add 1 part onto it, which is 1/3, and we're at 14/3, so we're at 4/3, and we're going to take away 7/3 to y. 2/3 plus 1/3 is 1, and 4/3 take away 7/3 is minus 1. So our answer to that question is going to be 1 minus 1. Next thing it's going to ask for is the coordinates of B. Now, B is the midpoint of BC. P is the midpoint of BC. So C, which is 4-2, travels to P, and that's 1 minus 1. That's a rule of, so C going to P is a rule of minus 3 to x and minus 3 to y. And then P, we'll do it in purple, P going to B would be the same rule again. So it'd be 1 take away 3 is minus 2, and minus 1 minus 3 is minus 4. Okay, next definition you guys might not be familiar with is that proves C is the orthocenter. What exactly is an orthocenter? An orthocenter is the point where all three altitudes of the triangle cut each other. So, in essence, it's basically a perpendicular line, that hits the opposite angle. Okay, is a orthocenter. Right here, you can see me messing with the orthocenter of a triangle. Okay, I can mess with it any way I want. The orthocenter is sometimes outside the triangle, sometimes it's in the triangle, depending on the angles. Now, all you need to know is that it's not the midpoint, it's just any perpendicular line that connects to the angle opposite it. So we're going to need two perpendicular lines which connect. So we're going to need a perpendicular line that goes through the angle opposite it. And if we get two of these lines, we can find the orthocenter of the triangle. Okay, so that's going to be our job. So what we'll start off with is we'll start off with A, C, and B. I'm just going to write down A, C, and B. 0, 6, 4, 2. So we have 0, 6, we have 4, 2 over here, and we have a B is minus 2, 4 over here. Okay, and that is A, B, and C. Okay, and for argument's sake, we're just going to set up a triangle just to represent it. Now, here's what we're going to do with an orthocenter. It's just the point minus 2, minus 4. This is 0, 6, 4, 2. An orthocenter is you basically get a perpendicular to any side, and you put it through the angle that's opposite that side. It's not the midpoint, as you can clearly see by how I'm moving it. So it's any two lines that are perpendicular to one side that go through a point. And where these 2 points hit each other is your orthocenter. Okay, so here's our 3 points here. And we're going to start off with is the slope of BC, which is the purple line here. BC would be x1, y1, x2, y2. And what we're going to get is 2. It's going to be minus 4, which will be 2 plus 4, I believe. And then on the bottom, it's going to be x2 minus x1, so it's going to be 4 minus 2, which is 4 plus 2. It's going to be 1 over 1. So the slope of BC, which is the slope of the purple line, is 1. Therefore, a perpendicular line to this, the green line, that goes through the point A, will have a slope of minus 1. Next thing we're going to do is we're going to get the slope of AB, which is this blue line here. And we're going to do the exact same slope formula as last time, y2 minus y1 over x2 minus x1. And what we're going to get, this is x2, y2. And what we're going to get is 6 minus 4, which is going to be a plus 4. And then it's going to be x2 minus x1, which is 0, minus 2 is a plus 2. It's going to be 10 over 2, which is a slope of 5. Now, this blue slope of 5, what we're going to do next is construct a red line that goes through C, which is perpendicular to the blue line, and it's going to have a slope of, that's plus 5, so it's going to have a slope of minus 1/5 when you turn it upside down and change the sign. Where the red line hits the green line is the orthocenter of your triangle. Next thing we're going to do is y minus y1 equals n into x minus x1, and we're going to do the equation of the line. Okay, and the equation of the line is the following. Minus 2. Okay, so we have y minus 4, which is y plus 4. Whoa. Okay, so we're after the green line first. The green line goes through the point 0, 6. 0, 6 is x1 and y1 because the green line goes through A. Okay, so it's going to be y minus 6 equals the slope, the green slope, which is minus 1, over x minus x1 minus 0. Then it's going to be y minus 6 equals minus 1x. Going to bring the x to the left and the y to the right because we're going to solve a simultaneous equation in a minute. and that is the equation of your line, the green equation, the equation of the green line. Now we're going for the equation of the red line. The red line has a slope of minus 1/5, and it goes through the point C. So C will be your x1 and y1. So it's going to be y minus 2 equals minus 1/5 into x minus 2. Multiply up the fifth, we get 5y minus 10 equals minus 1x plus 2. Bring the x to the left, and we're going to get x plus 5y. Bring the 10 to the right, and that equals 12. Next thing we're going to do is take away the 2 of these. So I'm going to multiply the green equation by minus 1 and get minus x minus y equals minus 6. I'm then going to get that 4y. Simple mistake this time. The x value was 4, not 2. So it shows you how focus is extremely important. And that's actually going to be 14, not 12. Okay, spotted that one pretty quickly, thank God. So we're going to get 4y equals 8 and y equals 2. Now that we know that y equals 2, we can say that x plus 2 is 6. So this means x equals 4, means the orthocenter is the point 4, 2.